Okay, so for this next lesson, we are going to be talking about transformations and the graphs of rational functions. So the first thing they tell us to do is to put the function y equals 1 over x into our graphing calculator, and we're going to fill in this table and graph. So we'll go into our graphing calculator, go to y equals, and type 1 over x, and graph it. So we can see our graph looks a little something like this. These blue lines here, so it gets really close to our y-axis here and here, never touches, and it gets really close to our x-axis, but never actually touches. If we want to be able to fill in that chart, we can press second graph, and it pulls up the table for us. The first value is at -3. So at -3, down here -3, we're at -0.33333 repeating, which would be the fraction -1/3. All right, and then we have -2. So at -2, we're at -0.5, which is -1/2. And then at -1, we are at -1. And then at 0, it says error. And then at 1, we are at 1. And then at 2, we are at +1/2. And at 3, we are at +1/3. All right, so now I filled in my chart based on those values, and I'm going to graph them over here. So we go out to -3 and over to +3 is the most we're moving on our x-axis. So if I go out to -3, I go down 1/3. So right about here. And then at -2, I go down 1/2, which would be just a little bit more than that previous. And then at -1, I go down to -1. So if I connect those points, look something like this. It says there's nothing at 0, error. And then I plot my point at 1, 1. And then I'm at 2, 1/2. And 3, 1/3. So I connect those, and it looks something like this. So just like in our picture, we can see that it goes along both of our axes, but it's never going to actually touch. So when we draw that, we draw these dotted lines to denote that they're never actually going to touch at those places. And we'll talk about those here in just a little bit. So it says, first of all, is there any value we can't put in for x? Well, if you put in 0, we get an error, so we cannot put in 0. All right, then it says, will the graph ever cross the y-axis? Here's our y-axis. Does it ever cross it? Meaning, can x equal 0? Well, no, it can never cross it. All right, then it says to list the domain in both set and interval notation. So set notation would be when we just write it as x is greater than some number, or x is less than some number, right? But we can see that this thing goes along the x-axis into the negatives forever, and it goes along the x-axis into the positives forever. The only place it doesn't exist is right here at 0. So in interval notation, we could write that it's all real numbers except x cannot equal 0. All right, and then for our interval notation, this is where you put it in the sets of parentheses. So we would say it goes off to -infinity all the way up to 0. And then it starts again at 0 and goes off to positive infinity. Okay, then it says, is there any value that could not result for y? Well, just as above, we said that we don't get a result for y when x is 0. So the value would be when x equals 0. Then it says, will the graph ever cross the x-axis? Meaning y equals 0. So no, it never crosses this line here. It gets real close, then it picks up and starts again over here, but it never touches. So no, it will not ever cross. Then it says, what is the range in both set and interval notation? So it's going to be very similar to our domain, right? It keeps going up forever, keeps going down forever, which would mean all real numbers. However, it does not exist right here at 0. So y cannot equal 0. And if we were to do that in interval notation, again, it would go from negative infinity to 0, stop at 0 because there's nothing at 0, and then pick back up right after 0, going off to infinity. All right. Then we have some blanks to fill in here. It says if the graph does not cross the x and y axis, we have something called an asymptote. Okay, and asymptotes are just invisible boundaries that graphs do not cross or touch. So they'll never touch. Unless they're horizontal, then sometimes we have an exception there. But to show an asymptote in your graph, you draw these dotted lines like I drew here. So there is our vertical asymptote running on the y and our horizontal running on the x-axis. All right. Then it says y is equal to 1 over x is a reciprocal graph. And it is a parent function. So remember, parent functions are just the original with no change made to them yet, which is exactly what is happening there. And this graph is actually called a rational function. All right. So now we know that this is what the parent function looks like. It has these points, and it has a vertical and horizontal asymptote. Okay, so then we have two possibilities here. We could have one where the top is just 1, or our top is some number a. Now, when that number is positive, our graph stays the same as the parent function. But remember, when our first term is negative, that causes reflection. So it will reflect if we have a negative a value. All right, now remember, h, the part with x in the parentheses, is left and right, and it's opposite of what it says. So it says plus, then that really means that we shift left. And it says minus, that really means positive, which would mean we are shifting right. And then k, our number out here on the end, if it's positive, tells us to shift up. If it's negative, it tells us to shift down. So still our same rules apply. All right, then it says that we are going to treat the coordinate point 0, 0, the center of our graph, as the vertex. But obviously it's not because we couldn't plot a point there. It does not exist at 0. However, it is the center of our graph. And any shifts that we make, left, right, up, down, are going to happen at 0, 0 every time. So we will move however much from 0, 0 that our graph tells us to. Our asymptote is also centered at 0, 0, so they will shift left, right, and up and down as well. So our dotted lines will shift. So we will say that HK is our new center, or our, what we said is kind of like a vertex. Then we will go right and up 1, then left and down 1, unless A is not 1. So the reason we'll go up and right 1 or down and left 1 to plot our points is because if we look at our chart here, that's where our whole number points were, right? Okay, so let's give that a try. So keep in mind our new center is at HK. We have a vertical asymptote at x is equal to h and a horizontal asymptote at y is equal to k. So it says let's practice identifying our asymptotes, which is our new center, the domain, and range for each of the following. So on number 1, we have the graph or the function 1 over x plus 2. So remember, opposite of what it says, this really means that we are going to move left 2 from our starting point at 0, 0. So I'm going to move over 2. And this is my new center. So my new center would be right there at -2, 0. Okay, now remember, this is my h, this is my k. So my vertical asymptote right here is at x equals h, and h is -2. So I have a vertical asymptote, remember vertical means up and down, at -2. Remember we draw an asymptote with our dotted line. Horizontal asymptote is y equals k, and in this case k is 0. So along the line y equals 0, I have a horizontal asymptote. Okay, so this is my center. We said that we would go right 1 and up 1, and from here we would go left 1 and down 1. And then we just draw a sketch of what we know our graph will look like using those points. So our graph would look something like this. All right, so my domain, it's still going to continue going left and right forever, but now instead of not existing at 0, it now does not exist at -2, right? That's where our asymptotes are. So I would say that my domain is all real numbers except x cannot be -2. And then for my range, so my y values are going to go up and down forever, but it does not exist at 0. So y cannot be 0. So all real numbers except y cannot be 0. So when you're writing your domain and range, you're basically going to take your vertical and horizontal asymptotes and say that they cannot exist there. All right, number 2. So this part, -3, really means opposite. So this means right 3. And then the number up here would mean up 2. So we're starting at 0, 0. I'm supposed to go right 3 and up 2. And here's my new center. So my new center is at 3, 2. All right. So I have a vertical asymptote right along here. So at x equals 3. And I have a horizontal asymptote at y equals 2. So x equals 3, y equals 2. My domain, so when I draw in my graph, remember I go up 1 and over 1, and down 1 and over 1. Draw in a sketch of my graph here. something like this. So it's going to continue left and right forever, which would be all reals, except x does not exist right here along my asymptote at 3. So x cannot be 3. Now for range, again, it's going to go up and down forever, except it does not exist at y equals 2. All right. Then here we have a negative. So remember, negative means reflex. Okay, -1 here, opposite of what it says. So really we're going to go right 1. And then this would mean down 3. So I go right 1, down 3. So here's my new center at 1, -3. So I've got a vertical asymptote at 1 and a horizontal at -3. All right, so our vertical is at 1, our horizontal at -3. Now, reflex means it flips it over. So normally our point is here. Now it's going to be down here. So now this is our over 1, down 1. And this one that used to be our over 1, down 1 is now our over 1, up 1. So it just flipped our insides pieces to the opposite places. So normally we're up here and down here, it reflected it, flipped it. All right, so domain, still all real numbers, except it does not exist right here at 1. And range is still all real numbers, but y does not exist at -3 on our asymptote. Okay, next example, we have a +3 in the bottom. So remember, that really means left 3, and then we have a -1, so down 1. So left 3, down 1 is at my new center. So my new center is at -3, -1. Okay, so I have a vertical asymptote at x equals -3. So I draw that in over here at -3. And I have a horizontal asymptote at -1. So y equals -1. All right, so now we have to go in and actually draw our graph. Remember, we had something over here that says that we will go right and up 1, left and down 1, unless a is not 1, which would be this case here. All right, we have a 3 for our a value. Well, let's just pull up our graphing calculator and see what kind of a change that would actually make. So let's see here. We would go into our graph, and instead of 1 over x, let's do 3 over x. All right, so it still looks a lot the same, but if I go in, remember if we had -1, it was supposed to be at +1, and now it's at -3. Okay, if we were at 1, it's now at 3. So basically, instead of going right 1 and up 1, or right 1 and up 1, we're now going to go right 1, up 3, down left 1 and down 3. So I'm still going to go over 1, but now I go up 3 places. And I'm still going to go over 1, but now down 3 places. Okay, and then we just draw in our sketch. And it looks something like this. All right, so our domain should still be all real numbers except where our asymptote is, which is at -3. And our range should still be all real numbers except where our asymptote is, which is at -1. All right, example 5. So here we moved -4, which would really mean moving over to +4. And it did not say we moved up or down any, so I'm now at 4, 0. I did not move up or down. My vertical asymptote is at x equals 4, so I have a vertical here at 4. And since I did not move up or down any, my horizontal stays at 0. All right, now, again, we have a value that is not 1 up there. It's going to do the same thing. Instead of going over 1 up 1, we now go over 1 up 2. Instead of going over 1 down 1, we go over 1 down 2. And then we just draw in our sketch. And it looks something like this. So again, our domain should still be all reals except at our asymptote of 4. And our range should still be all reals except at our asymptote of 0. Okay, example 6. So we should notice up here that negative means to reflect. So when we go to draw in our points, they will be flipped. It did not move left or right any, but it did go up 2. So now I'm up here at 2. So my new center is at 0, 2. That means I have a vertical asymptote at 0, since I did not move left or right any. And I have a horizontal at 2, since I shifted up 2 places. Okay. Now, when I go to draw in my points, remember we normally would go over 1 up 1. Now, since it's reflected, I'm going to go over 1 down 1. And over here, I normally went over 1 down 1, so I'm going to go over 1 up 1. And we draw in our sketch. And it looks something like this. Again, our domain should still be all reals except where that vertical asymptote is at 0. And our range should still be all real numbers except where our horizontal asymptote is at 2. All right, last set of examples here. All we are doing is graphing them and then stating their domain and range. So, first of all, it did not move left or right any, just moved up 1. So my center is here at +1. So I have vertical asymptote at 0 and a horizontal asymptote at 1, since it was shifted up 1 place. All right, and it does not have a reflection, so we go over 1 and up 1, over 1 and down 1, and draw in our sketch. Remember, these are always approaching the asymptotes but never touching. So now I just state the domain and range. So first, my domain, well, it should still be all real numbers except at our asymptote. So x cannot be 0. And our range should also still be all real numbers, except it cannot exist at our asymptote of 1. All right, number 2, we have shifted over 2. Remember, -2 here would really mean to the right 2. So I'm right here. We did not shift up or down any. So we have a vertical asymptote here at 2. And a horizontal asymptote at 0, since it was not shifted up or down. Now we do have a negative up here, so instead of going over 1, up 1, I go over 1, down 1. Instead of going over 1, down 1, I go up 1, over 1 for this side. I draw in my sketch, approaching the asymptotes on either side. And then I fill in my domain and range. Well, remember, our domain should still be all real numbers, except it cannot exist at our vertical asymptote of 2. And our range is still all real numbers, except at our horizontal asymptote of 0. Last one. We have shifted 5 to the left and up 3. So over 1, 2, 3, 4, 5, up 1, 2, 3 is my new center. So I have a vertical here at -5, and I have a horizontal here at 3. So now I need to draw in my points. It is reflected, so I go over 1, down 1, over 1, up 1. Draw in my sketch. And there we go. Now I just need to fill in the domain and range. So our domain should be all reals except at our vertical asymptote, which is at -5. And our range should also be all reals except for our horizontal asymptote, which is at 3. So remember, all of our changes are being made to our parent function that looks like this.